Hello everyone, my name is Alex Live and I'm very happy for today's stream. I'm very excited for today's topic and the guest today with me. I have Thomas Wurtinger, who is of course the founder of GraalVM and the lead for the project currently. And the topic for today is of course the GraalVM 21.2 release unboxing. We're gonna look at what's coming in this release. We're going to look at the certain features of the components, and we're going to see some demos. Hopefully they will work. And we'll talk about what is exciting in the release, why we think certain things are exciting, and we'll try to answer your questions if you have those about the release. Thomas, how are you? How are you doing?
Cool. Excellent. Thank you. Thanks, Oleg. Yes, cool. Yeah, today we're going to do the 21.2, but we also released a patch update for 20.3.3, right? You have here the page with the versions of GraalVM open, and we have like a very determined release schedule. So the releases are fixed on a certain date, and 21.2 is a feature release, and at the same time we are also patching the last feature release from last year, which is 20.3. So if you want to be on the latest versions of GraalVM, use the current year, meaning 21.2, 21.3, etc. And if you want to have sort of a little bit of an older but more stable version, you use the last version of the last year, so 20.3.x. So in this case now 20.3.3 with the security updates. Yes. And yeah, so like what is like new in that release? Can we go through some of these items?
Right, of course. So we're gonna concentrate on 21.2, which is a feature release. So we're gonna talk about what's new in there because, well, the stable release, sort of the whole point of that is that it doesn't it doesn't change much, right? So what's new and exciting in 21.2? Before we start, I want to tell you that I have a dev build of this version available, and I will run my demos using that dev version of GraalVM. Right, and if you want to,
and we actually we like publish dev versions, right, as well for the community.
Yes, we do. So the release is not out yet, as far as I know. But if you want to follow us on what the demos that we're running, what you can do, you can go to the github.com/GraalVM/CE dev builds, which is the development builds that we publish. They're not exactly nightlies, but they're regular of the branches that we currently have in development. And at the very top, there is, of course, the 21.3, because that branch now is in development. But if you scroll a little bit down, you can see that there is the pre-release of GraalVM CE 21.2 dev build from a week ago, where that branch was in stabilization. So everything that I'm showing here should work on that one. You can try that if you are eager to follow these demos right now. And then if not, just follow our socials, and the releases will appear in their usual places whenever the builds are ready to be published.
Right. Yeah. And so these dev builds, like as you see here, this one's already online since 8 days, public. We really appreciate if community members or people like developing frameworks related to GraalVM are testing extensively on these dev builds. Because we kind of create these dev builds once we are in our feature freeze phase, which is rather short because we have such a frequent release schedule. But still, we have a couple of weeks of feature freeze, and in this phase, it helps us a lot if the community can download these dev builds already and test with them, so we find any last-minute issues.
Yep, exactly like that. So without further ado, let's look at what's new and exciting in GraalVM 21.2. So I have a couple of slides here, and I want to start with native image improvements, which is probably the most exciting component of GraalVM. Very many people actually equal GraalVM to using native image technology for building those native binaries, but this is just a part of that, though very exciting part, so we'll start with that right now.
Yeah,
And there are a
and
number
so
of improvements.
a native image, like, yeah, I mean, it's like, it's the most exciting part is because it's such a good performance. But one of the things we try to now address more and more is like the develop usability aspect of this native image. And in this release, we already have a couple things like you mentioned. But in general, it's sort of a new focus point for us to make sure native image not only provides you the best performance when running your cloud application, but also provides the developer experience that is excellent.
Yes. And one very exciting feature in this release is support for JDK flight recorder monitoring with native images. So for this one, I actually have a small demo that I have prepared, and let's look at that. It's
yeah, and maybe to mention here as well, like this JDK flight recorder effort has been a collaborative community effort. We have here worked together, like engineers from the GraalVM team at Oracle and engineers from a team at Red Hat have together put this functionality that now enables this Java flight recorder on for native images.
Yes, and what the JDK flight recorder does, it's a sort of a very low overhead monitoring solution that you can use to record on demand certain metrics from your runtime system, right? So like on the JVM, it will give you the information about the CPU usage and memory and locks and GC events and all kinds of events. And it is very helpful because you can profile all your applications this way. So, and the central kind of sort of entity in this in the JDK profiling is the event notion. An event that you can create, and you can not only can use the predefined events that come with the JDK class library, for example, but you can also define your own events, and you can kind of sort of use the same infrastructure of the Java JDK flight recorder to emit those, and they will end up in the logs. So here's a very simple application that will try to convert to native image and show how you can use JDK flight recorder events in the native image, right? So it does a very simple thing. It creates an event, which you just label that using the annotations from JDK GFR package, and you create that and you commit those events. So if we run this application, let me just see which folder I am here. Native image, GFR, right? I will do Java example class, right? It does nothing. It doesn't print anything because there is no actual output, but it just creates an event and runs that. So it creates this recording GFR file that I will remove to show that everything is clean and nice, right? So there is no file here. And I will build this application now into native image. How do I do that? I do native image. But first, let's do Java minus version. We are running GraalVM Enterprise Edition 21.2. This would also work in the Community Edition, of course. But this is the dev build I have here. So I will do native image. I need to enable the VM inspections. I always forget what's the correct allow VM inspections, right? That's the correct flag here in the terminal. And I will just do example. Native image now will build my application, right? Which consists of a single class and the JDK class library classes, and it will build that into this binary with the VM inspections built in. So that will allow me.
So yes, what does it mean, this allow VM inspections? It
yes.
enables something like it enables the built-in flight recorder.
It enables the built-in.
Or just in general, it enables.
It adds the support for flight recorder being in the binary, right? So it puts the infrastructure for that into the binary. So by default, this application, you can start it with the flight recorder or without it, like a normal application. But the code that enables that will be in the binary. It also enables a couple of things specifically for the in the Enterprise Edition. For example, you can get the heap dumps and some other VM inspections features, sort of like that. But in a nutshell, for the flight recorder, you want to use that option to just run it. And now what I can do, I have the example file here. So example, right? Very simple. We have this binary file. We just built it.
Yes, and so here you also have this printing build artifacts. What is in this build artifacts?
Yes. So if we look at the example build artifacts, this is just, it shows what files have been created. So if you're building a shared library, for example, it will give you the shared library name and also the header file names that give you the idea what's in there. And I think also if you're building with some reporting options, then I think it lists the files where it reports things here as well, which is a helpful sort of feature. Right. So I can run, you can see I can run this example thing here, and it doesn't produce the JDK flight recorder recording log yet because I need to enable those. And I enable those using the normal thing, right? The normal parameters. So I need to run my example here, and I also enable the flight recorder, right? And you know that we already added the support for the binary for flight recording into the binary, and I also say the start flight recording command, and I give it the configuration options. There are a number of those options that you want to use. So specifically, for example, on the JVM, very often you delay the recording of the slog because the VM needs to do a lot of work at the startup. So maybe you don't want to record the information there, but you want to concentrate on kind of more stable workload where JVM runs your code. The same options are available here, or at least to a certain extent, but you can start the recording. And now when I run this, now we should have the recording file here again, right? So this is the log with all the events that are created and run from the execution of our command. And how
is this GFR file is a binary file, or is it a text file?
I think it's a.
Can you just try to cat it? Yeah.
It's a binary file.
It's a binary. All right. So we need now a tool, either GFR, or we can also use VisualVM to open this.
Yes. So we're going to use VisualVM, and I'm starting this VisualVM process right now. I already have one. Okay. Very good. So I'm going to delete the last one. This is my VisualVM here. I will open the file. I say add the GFR snapshot, which is the recording, and I will browse to the execute that file that we created. So where do we go? Repo, demo, back. We don't want to debug JavaScript. We want the demos, native image, GFR, and we save the recording. We open that, we say, okay.
We need to delete the old one.
Yeah, remove the old one. Or we needed to change the thing, change the name of the file.
The name, yeah.
Okay, we do it again. Repo, demos, native image, GFR, recording, open. Okay, right now we see the recording here. We can open that. And the interesting bit here is, of course, you can see that there is a bunch of information that you get. So the monitoring, the threads, but we want to concentrate on the browsing of the events. You can see there are a number of events available here. Our Hello World uncategorized event is here as well, with the message Hello World available there. It's not the most sophisticated example, but you can see that. And it also, for example, gives you the information about the various execution environment
variables, right? System properties. What does it say on JVM information? Yes, it tells you which GraalVM version this was built with, right? Yes, this was.
Yes, some things like that. It also gives you for example, the total size of the physical memory available on the machine, and so on. So the thing is, specifically in the current release, the main focus for the JDK flight recorder was to add the infrastructure for this and add the infrastructure for the custom events. So you can use that. Not all events that you would expect from the JVM world are implemented or correctly show the information here. That is the subject of the ongoing work. But you can absolutely...
So in the future, there will be more of these events. And
yes, but what you can do now absolutely is to send your custom events from your application specific metrics or repurpose maybe some adapters from the, I don't know, OpenTelemetry to GFR, something like this. This is a very interesting contribution. This is a very interesting collaboration in the community, and I personally am very happy that this monitoring effort has landed for the native images. because GFR metrics and monitoring is sort of one of the de facto ways to monitor Java applications. And this brings native image one step closer, not in terms of like actual compatibility, but in terms of the usability. It behaves the way you expect it to behave, which I think is a massive, massive step forward. So that is that. And then another thing that I wanted to talk here about with the native image is the plugins for native image for build tools, right? And this is something that is not exactly the part of GraalVM, but if you GraalVM build tools plugins, we released that a little bit early. We released that back in June, right? And what is this? It is the plugins for Maven and Gradle that simplify working with native image. There are two main things that they do. One is they simplify building native images from your Java projects. You just enable the plugin in your build system, and then it knows how to configure GraalVM and how to configure native image specifically, and how to pass the class path to it. So it takes a lot of configuration on itself. And this is one thing. And we had the Maven plugin before that was doing the same thing, but now we are taking it to the next level. There is also the Gradle plugin, and very, very exciting thing is that they not only allow you to build native images, but they also allow you to run your unit tests in the native image mode. So what it means is that with a simple configuration, just applying a few plugins, a plugin to your build Gradle or to Maven POM XML, what you get is you get the tasks in your build lifecycle that you can use to run unit tests from your application or from your library in native image mode. What it means like functionally is that at a certain stage, at a certain task execution, native image will look at all the tests that you're running, and it will build the binary that will contain all those tests, and then it will run and call the methods which are the actual tests, and execute the code and execute the assertions, and you can verify that the behavior that you expect your library to show also is present in the native image mode, which I think is the most useful. Like, it is useful universally, but it is very, very useful for people who maintain libraries in the ecosystem, because then you can run your library, you can run your unit tests in native image mode, and then you can be confident that your library works as native image, and that if people and your users will come and ask, oh, do you know if this works as native image? You can proudly show the CI/CD pipeline where you run those tasks once in a while. So I will show a very simple project here, and because I think this is interesting. So I have a Java application with tests here. It's a Gradle project. It's very simple. It's a very simple application. It just does nothing. It prints the hello world, but it also has the calculator class, which we're gonna test. And we have a bunch of unit tests here for the calculator. So 1 + 1 = 2, and the 1 + 2 = 3, and parameterized tests. So this is the JUnit tests that we're gonna try to build as native image, and then run in our application. So, and I want to show how to do this. So I'm gonna use Gradle, and what I need to do, I need to enable the plugin for the build tools. So I say that I want the GraalVM build tools native plugin enabled, specify the version. You can see, like, back in June we released 0.9. Now we did the 2 bug fixes releases. So this project iterates even faster than the GraalVM binaries. For now, you also need to specify that in the settings Gradle that you want the repositories, because I think they're in the Maven Central, but this step will go away when those plugins will propagate to the plugin portal for Gradle, right? So we enable the plugin, and that's all. That is all, literally, what it takes. So let me just go back and let's go into plugins, Java sample application with tests. What I can do Gradle build, right? And this
Gradle, yes.
Gradle build. And this is our normal lifecycle for this application. So it will run the normal stages, normal tasks, and it will not run native image, right? So it will not we know that native image build takes a little bit of time. It takes a little bit of the resources. So this is not something that we want to execute maybe on every commit or every execution of the Gradle build. However, if we run Gradle native test, there are a few tasks. While I'm running this, let me just show the configuration here. So there is native build, which will build your application in native image, native test task, which you can configure and read the docs, and it will run the tests in native image mode. So let's see what it does. Now,
and can you go back to this native build? Like, yeah, we can put JVM args here or build args, right? So this is a couple parameters that are interesting.
Yes, there are the interesting parameters usually are the image name, which is specifies the binary name and the output, the main class, which we need for determining what is the entry point into your application, build args. This is where you would probably put no server, no fallback, and some other configuration for the native image. You can see there are some other things, class pass, the flags, JVM args. This is interesting. This JVM args is the flag that you pass. You pass the options for the JVM, that is the native image builder process, because native image in itself is a Java application. So you can, for example, debug that using the Java debugger if you would like, or you can configure, for example, how much resources does it take, is it allowed to take. So you can set up the heap size. You can set up, for example, the parallelism that it allows to exhibit. So if you're running it on not the most powerful machine, or you want to, for example, limit the impact it has on your hardware, because if you build it on your local machine, then maybe you don't want to give it all the CPUs and all the memory, because you might be running Slack and Zoom as well as just the build process, right? And then it is a very handy flag where you can use, say, like, oh, use like 6 gigabytes of RAM and like 4 CPU out of my 6. The build will be a little bit longer then probably, but at the same time, you can configure how much resources it takes. And you can also configure different things for the build. And the same options are available for the tests. So there are two different executables that will be built. The native build builds the application, and native tests builds the tests, which is the executable with the tests, right? So you can also have an option to run with the tracing agent, which is a very interesting option, because, well, maybe you need to produce the configuration for the native image builder from the traces that you run when you run your application in the JVM mode with the tracing agent. So it can automatically capture the reflection configuration, proxies, classes that you want to load at runtime, and so on, serialization data and whatnot. So quite a bit of options, very, very flexible approach here. What is very good, in the native image, if you invoke it from the command line, you need to put all those things either in the native image properties file or directly on the command line, which means like a separate script normally. But here with the plugins, you can embed that into your build configuration for the project, and it's a very good approach. To be honest, I think we should have done that before, but it's not easy, and I'm very happy that we found resources and time from the team to deal with this now. Right, let's see whether that project actually succeeded or not. Yes, wait, this is where did I run this? Yes, so let's explore what it gave us here. So it ran for a minute, right? And it built the native image application. So it printed the build artifacts. You can see that it was actually not such a long execution. So on my machine, the very simple hello world takes almost as much time, which means that like you can run like if you have more tests, it will add a little bit to this timing, but it will not be critical. And then it writes the native image test, and then it runs that.
Right, and it builds one image for all tests, right?
Yes, it's a single image for all the tests. I think we can look at the size of that ls-lf, this thing.
Yeah, 25 megabytes.
I don't trust my 24 megabytes, right? So it's a reasonably small application, given that this is the Mac-based native image. And you can see that then it runs the tests. So it has a list of tests that it needs to run that are either determined from the platform in integration with JUnit, or that are determined by running the agent and noting which tests we're running. So and then it runs the same way and executes the assertions, and it prints the results. You can see that tests finished in like 100 milliseconds, which tells you that it actually runs in the native image mode, because like in the JVM mode on my Mac, it doesn't start in 90 milliseconds just to do anything. Right. So this way.
Yeah. So we have one question here from Christoph Dont. So the native image configuration is separate for the native build and native test. Or does the test setup use the build properties? Can you go to the?
Yes, I can go there. The native build and native test are separate, because you might want to have, like, one is builds your final artifact that you want to release, and the other one builds the test artifact that you want just to run, and then, well, discard that or store it somewhere in your pipeline, but not actually release anywhere. So you might have different options. For example, if you want to generate the debug symbols, maybe you want them for the tests because you want to debug that, and not want them for the for the actual runtime artifacts, right? And there is also a question in the chat whether there are the same features on the Maven plugins. Yes, so the Gradle and Maven plugins are equivalent in functionality, and then I think they even share some common code here. At least that's the idea. So the same sample project here, you can see I have the POM XML and native. Right, this one uses the snapshots. Then you can see that there is a configuration for the profile native, and it runs the tests, build the native image. So Maven and Gradle here are equivalent. You can run your unit tests. The thing that is maybe not the most kind of limiting currently for this is that integration with the unit tests is for the new JUnit 5.x branch, which means that if you're using an older JUnit still, then you might need to upgrade for this. Because the reasons for that is that there are some changes that are also implemented on the JUnit side, and some changes are in the JUnit platform, and that's how this integration works.
Right, so you need the latest version of JUnit.
Yes, and also, like, I think Kotlin test works, but I have no certain information, so you should try. And I think like various frameworks like Spock, for example, don't have the integration with this. Like, we don't have the integration with them, so that might come later. But currently we are focusing on JUnit as the de facto standard for the tests. What would be very cool with this is that if you are maintaining a library, like in the Java ecosystem, it would be very interesting if you could try the plugins and enable them on your library and run the tests. Maybe you don't want to run them like on every commit and every PR, but at least you can enable maybe them for the nightly runs, and then ensure sort of compatibility with native image, that your code works the way you expect it to work in the native image mode. Do we have any questions? Any more questions?
Yes, one more question. So you should put your production configuration config file, so the native tests will also pick this up, right?
Yes, you can put the configuration. The idea is that you put the configuration in the config files and native tests will pick them up, right? So this is for example, the meta-inf native image folder in your jar files that you want to put on the class path, where you can, for example, specify which files and which classes you want to open for reflection usage, or which proxies you're creating. Then the test will pick that up. And at the same time, yes, if tests do not pick something up, they will probably fail, right? Because you your test does exercise the code pass, and like it is there to tell you when something is insufficient or not working, right? So if you're not exposing this configuration necessary for the building the native image in the tests enough, then they will fail and notify you about that. But yes, like so, like it should work the way you expect it, right? Right.
Cool.
I have a question from NeoMatrix. Is how would you pass to generate the PGO flag? This is a very interesting question. I don't have a good answer for that. So PGO is a profile guide optimizations that you can enable for the native image build. I don't have a good answer for that because it requires another stage where you build the native image, instrumented native image, and then you kind of gather the profile and run the native build again. Probably you want to do that with the CI/CD pipeline anyway. So you run the native image
right,
build
but
once.
we could. I think it's an interesting feature request for this plugin to like support this lifecycle because there. I mean, we could. You almost kind of want to run the tests or some tests that you designate as benchmarks, and then the whole PGO gathering the profile guided optimization would be automatic.
Yeah, yes, but like it also, like I assume that it depends on the quality of the benchmarks and how relevant they are for your workload. I mean, like no profile information would be worse than like, or maybe it could be than no profiling information, but in general it just complicates the build a little bit, and maybe we can add that in the next iteration somewhere.
Yeah, I think it's an interesting feature request we should discuss for this plugin.
Very well. Very, very good. Right. So yeah, this is native image. Two things that I wanted to cover. There are more also other improvements here. So build tools, running unit tests, do that and tell us how you work. And then there are a number of other improvements, which are also like the whole release is, I think we focused on the native image usability improvements very much. So there is the resources in native image now behave as a file system. So you can use the file system API to read the files, write the files, read the like attributes for the files. It behaves the way you expect it to behave. Right. We added a feature where the static analysis is now sophisticated enough to remove the security providers unnecessary, like not use security providers from the native image, and include the used security providers automatically. So there was a flag that enabled all security services. That is now deprecated. You don't need that anymore. And then also a very exciting, cool thing that was, I think, delivered in cooperation with engineers from Alibaba. The loading of new classes. So the APIs for the class loader loading classes now is working at runtime of the native image. It doesn't load arbitrary classes, but if the classes that it needs to call and load are available at the image build time, then you can include them into the predefinition and they will be included in native image, and then calls to class loader load classes will actually succeed, which is very good, right? So this is the combination of the closed world assumption, where all the classes and all bytecode need to be seen at the build time, and also this dynamic nature of calling the load class API at runtime. So native image works better and better for more and more applications, and you should absolutely consider using that if you're running any cloud workloads or any workloads where startup and memory consumption are important, or where you want to distribute the application as a single file.
Cool.
So yeah, that's native image. Oof, we are taking a little bit too much time here, but this is fine. Let's talk about the compiler quickly. After all, very many people say GraalVM native image, and we disagree, but we talk about native image quite a bit as well. So just-in-time compiler. This is a little bit of your area of expertise, Thomas. So maybe take it from here.
Yeah, so like GraalVM at its core is still just a compiler. It's not native image, it's not Polygon, whatever. It's the core system is a compiler. It's the GraalVM compiler that we use both in the just-in-time and in the ahead-of-time compiled mode. And in a compiler, like you have tons of optimizations, and we are actually in every release almost adding a couple new optimizations because the amounts of possible transformations to your program that you can do is really, really high. I mean, it's kind of infinite. The types of transformations that can potentially improve the quality of machine code that is generated. And so every 3 months, whenever we release GraalVM, there's like some performance improvements. They might show up in some workloads, maybe not in others, because the way these things work is kind of you make the performance improvements, and then like some fraction of the workloads get like 5% faster, 10% faster. But as we iterate and iterate, like then at some point, the sum of all these optimizations just give the GraalVM compiler like a big lead on average versus other compilers. And in this last 3 months, we added a new SIMD vectorization support for sequential code. And so, so previously in GraalVM, we did vectorization already. We were vectorizing the loops that we could recognize as such. And so here we see a simple loop, for example, that runs over some array. And then on Intel hardware, we can now use, for example, the SSE instructions or the latest AVX instructions to have a vectorized version of this loop, and then it's going to run better. And so previously, in the previous versions of GraalVM, we were primarily focused on this loop vectorization. And now since this 21.2, we are now also vectorizing linear code, meaning this is code that is not directly executing in a loop, but we see still an opportunity to vectorize it. So in this scenario here, the programmer might have manually unrolled the loop, or he's just assigning a couple fields. And so then we would in this scenario now in 21.2 also recognize this as a structure that we can use a vector instruction for. And so this is a difficult problem for us because in terms of, we always need to do here trade-offs because it's like changing the instruction set, for example, in Intel between vector instructions and non-vector instructions can have a penalty. So the compiler needs to be really smart about in which scenarios this linear code vectorization will actually gain an advantage, or in which scenarios it might make things worse or doesn't gain any advantage at all. And so we finally put together this algorithm that is making sure that it applies this technique only where an advantage is visible. And we tested this with our benchmarks and could see across the board quite some improvements. And this is one of the new additions to the GraalVM compiler optimizations. And we still have more optimizations in the pipeline. So when you tried GraalVM Enterprise specifically on some workload, it certainly pays off to try the latest version again and see if maybe the latest version is now one of the optimizations in them is helping the performance of the latest version.
Yes. So, and this linear vectorization is available in GraalVM Enterprise, right? And it's also an experimental currently. So this is not enabled by default, and you can turn it on with a certain flag that you can look up in the release notes.
Yeah, so we encourage folks to try out this flag on their workloads. We haven't have it enabled by default because it is a fairly substantial change to how we generate machine code. So we want to have it tested for a longer time before we are comfortable enough to enable it by default.
Yeah,
because the core of the compiler for us is always also the most critical part. If the engineers working on this part make any kind of mistake or there's any bug in this, the results can be really, really bad. Because it could mean that any application running on GraalVM would suddenly basically run arbitrary kind of instructions that could cause damage. And this is why specifically specifically for this part of the project, we have to be extra careful not to add anything complex that we would not actually have fully proven to be correct. We have a research collaboration also in this area with an Australian university, where we are working on proof verification for compile optimizations. So we can not only have our tests and our own reasoning for this, but we can then also with this academic collaboration prove the transformation is actually correct.
Excellent. That is very exciting topic. So Gilles there in the chat tells me that the option to enable that is -d graal vectorize SIMD, capital SIMD equals true. And try that on your workloads. Try that with Quotient as a experimental optimization, but it can bring a substantial performance boost to your applications if they feature the code paths like this and patterns like that in your code. Right. And another cool thing that we have in 21.2 is the speculative guard movement, which is another very interesting optimization. Maybe you can take us through, or maybe I should take us through the sample code here.
Yeah, so I mean, I can talk on that. Okay. Like we have, like in terms of our optimizations, one thing we do is sometimes we make a guess about something, and if the guess doesn't hold, then we can go back to the interpreter, which is called the optimization. And this kind of optimization is not available when you build a native image because it's ahead of time compiled code. But this optimization is available for in our just-in-time compiled mode, either running on top of Substrate VM or running on top of Hotspot. And so in this example here, in this example code here, we have a for loop with some condition inside, and within that condition, we are adding the neg adjust value. But the neg adjust value here is boxed. It's a boxed integer. It's not a primitive integer. So what happens now in the code based on Java semantics is that there is a null check, meaning before we can unbox this integer and access its actual value, we need to check that neg adjust value is not null. Because if it is null, we need to throw an exception. Now, this parse, unfortunately, makes this whole loop substantially more complex than it has to be, and can also then lead to issues for us to vectorize the loop and do better optimization with that loop. So ideally, we would actually like to not have this null check in this loop, but move it somewhere else. And in praxis, we assume that most applications don't rely on that null pointer exception to be thrown. So in most scenarios, we assume that neg adjust will never be null. And so what we do now here in GraalVM since the last release, and this is an optimization that also is in both editions. It's both in the community edition and in the enterprise edition, where we are moving this check before the loops. So instead of doing this check on neg adjust not equals null within the loop, we move the check before that for loop. And because like it's a speculative optimization, meaning we cannot actually guarantee that before that for loop that value is not null, we have to like de-optimize there. We need to have something where we can jump back to the interpreter. But now, and if the speculation fails once, we need to kind of undo this optimization. So it's an optimization that we can try to do. If it works, the code will be faster. If it doesn't work, we need to de-optimize and then like go with the slower version of the code. But if you're lucky here and the neg adjust value really is never null in the application, then we have now simplified that loop, and that loop can then be vectorized and lead to a very, very substantial speedup. So this is a very interesting optimization problem because of its speculative nature. And we now added it, and this is an optimization which will make here both enterprise and the community edition both faster. And it's one of the reasons why GraalVM as a JIT compiler as well is for some workloads better than alternative compilers, specifically for workloads where such patterns of boxing, unboxing, like in this scenario, are happening.
Excellent summary. I couldn't have said better. Yeah, so if you're running GraalVM Community Edition, well, you always have a reason to upgrade, right? But now you have also performance reasons to upgrade to check the behavior. Because,
right, and yeah, I mean, one more addition here, maybe as a comment, is that in this code, there are also additional checks for the array accesses, like ints at I is, for example, an array access. In this specific scenario, we can actually prove that the array access is not necessary because the value I of the loop is running between 0 and inst.length -1. But in some scenarios, you might have just I smaller size, for example. And in those scenarios where these bounds checks cannot be proven, also the bounds checks are moved speculatively out of loops. Yeah, so if you've previously benchmarked GraalVM, either Enterprise or Community Edition, certainly give it another try with this latest release, because this optimization should again give a few percentages on many workloads. And of course, it's always a small gain. It's almost a few percentages, but those percentages add up, because if every 3 months we are making the system like a few percentages better, we're very happy, because we know over like a few years, these gains are adding up a lot.
Yeah, and also, well, the important point is that the baseline here is very, very good as well, right? So it's not like you're starting with a lousy performance and improve relatively with large steps, but you take something that is state of the art and then you add it 2% here, 1% there, and over time that can create a very noticeable advantage. Anyway, the compiler is sort of very opaque thing for the users, so you should just use GraalVM as your JDK and be happy and enjoy the benefits of the hard work by the team. Right, let's talk about the other components. And there are a number of things that I want to highlight, and we are not going to go through all the languages that GraalVM supports. You can see there are like a bunch of there on the top: Python, Ruby, JavaScript, LLVM, Bitcode, R, and WebAssembly, and the community languages on top of that as well. But I just wanted to highlight at least something from this GraalVM language ecosystem. And Python is a very exciting language that a lot of folks in the community are asking about. So I wanted just to highlight a very simple example. Besides having a lot of effort on that concentrate on performance of particular languages or Truffle or GraalVM in general, there's also we're trying to always make the languages easier and make programs that contain different languages also easier to run and understand. So this is an example of that I took from the previous release, where we showed how on the Truffle level, there are now primitives for hashes, for byte arrays or iterators. So that means that those objects can be represented in Truffle terms, and languages can add support for that. And then the interoperability, when you pass, for example, the JavaScript hash to the Java part of the program, then you can use that as the normal Java map interface and use the normal methods with just a simple conversion. So in this release, Python.
Cool. Yeah, so this is the Python GraalVM stuff. Maybe before you continue, Oleg, we can answer one really interesting question in the chat. Maurice Meyer asks, could you discuss how GEP 410, removing TVMCI option in hotspot, will affect GraalVM going forward? So, so important to note here is GEP 410 is not removing TVMCI option in hotspot. So GEP 410 explicitly classifies that it is removing the copy of the Graal compiler that was shipped with as part of hotspot, but it is keeping the GVMCI interfaces. So this means, first of all, going forward, you will continue to be able to use the GVMCI interfaces with the latest jar files from the Graal compiler if you want to use the jar Graal, meaning Graal as a jar compiler plugged into Hotspot. Now, in general, however, we are not recommending this mode of execution because in this setup, it is often a little less tested, this combination of the Graal compiler with the specific version of Hotspot or OpenJDK. We do recommend in all scenarios that anybody who wants to use the GraalVM compiler or wants to use GraalVM languages or wants to use interoperability with Python here, like Oleg shows, anybody who wants to do that should use the GraalVM binaries that you download from GraalVM.org, because those binaries do have all of the components, meaning Hotspot, the GraalVM compiler, and its languages tested together. And on this setup and on these binaries, also GAP 410 has no impact whatsoever. And part of GAP 410 was to remove the Hotspot EOT option, meaning the option in Hotspot to create ahead of time compiled code. And part of the reasoning there is for sure that for ahead of time compilation, there are alternatives like GraalVM native image, where you can use the GraalVM compiler with substrate VM and ahead of time compiled mode. And the overall footprint and performance metrics in terms of startup are just substantially better with such a setup with GraalVM native image there, as opposed to using the GraalVM compiler in the context of Hotspot to do some amount of ahead of time compilation. I think that's the background on GAP 410, but also the bottom line in terms of for like GraalVM users is nothing changes. But if you want to use GraalVM or its languages, we recommend downloading the GraalVM OpenJDK distribution that is available from graalvm.org.
Yeah, a very good question. A very good question indeed. Thank you, Maurice. Right, back to Python. Right, back to Python. So here I just wanted to show that the similar interoperability between the Python dictionaries and Java maps would work the same way now in this release. And of course, this is not the only improvement that the Python saw. There are a lot of performance fixes. There are a lot of compatibility fixes. There is work on this HPy, which is a new foreign function interface for Python to better run native extensions. There is work on speeding up certain modules, specifically on GraalVM, like for example, serialization with Pickle, and so on. But this is a small improvement, and because it's a developer-facing features, I just wanted to show you. So here in this application, we initialize the GraalVM context, and we evaluate a piece of Python code that returns a dictionary. It returns a dictionary, so this is the curly braces and the key value pairs separated by the colon here. This is the dictionary definition. We wrap it with the type function declaration to return it to the outside, and then Python dict is used as a normal map here on the Java side. So here we have the var, but it also can be a map. And if I just do Java C main Java and Java main, we should see Aloha GraalVM, where Aloha is of course the greeting. And it runs, it compiles, it initializes the Python interpreter and everything, and it runs, and you can see that indeed it prints it out. Right? If you are interested in Python specifically and Python on GraalVM, we had just recently a couple of streams where we discussed how to organize Python code base and Java code base together, looked at some benchmarks and talked about that in details. I sincerely recommend looking at those, and just wanted to include the Python example here because the commitment to improve
Python is making Python is making great progress. It's still for early adopters and pioneers to try it out. So it's still an experimental component, and we are still not ready sort of for a really wide adoption. but they are making really great progress. And if you have certain use cases where you want to combine a Python library with a Java program, it is absolutely ready for that. And we are also happy to support POCs in this area, where like if you want support from our Python team to set something like that up, we are happy to assist there. And like I'm really excited about sort of this polyglot area of GraalVM, which has been now in the works for a very, very long time. But under the hood, this is still probably the biggest impact that GraalVM will have over the long run, because yeah, this polyglot environment that enables you to run here Java plus Python is very powerful, and we'll make sure that you can use the modules and libraries from the ecosystem wherever they are, and combine them in one. And we're constantly improving here the usability, like in this feature here, like in this example, where Python map is directly mapped to a Java map, and you can directly access it.
Yeah. How do we achieve that? There is the Truffle framework, right, which is provides you with the framework for implementing languages and the runtime for running them well fast, because nobody wants slow language implementations, right? So there are a couple of changes in Truffle which are very interesting. One of them is the new compilation heuristics for the Truffle languages, specifically that rebalances and reassesses the order in which the functions need to be compiled when you run them in languages on Truffle, right? So last release we introduced the multi-tier compilation. That was a very interesting feature targeting better warm-up, and now we changed the compilation queue as well, right? So for example, if you have two different functions which are both above the compilation threshold of the invocations, right? They are both in use, but one of them is much more in use before than the other. Then in the new release in the GraalVM 21.2, the higher usage function here will compile first, and that will increase the warm-up. So the policy now is just more sophisticated than just the hotness of the code, right? So how much it is invoked, but it takes into account what tier of the compiler you are trying to compile for. So the first tier proves to be more valuable because the speed up from the interpreter to the compiler is much more than from the compiler to a more optimizing compiler. And then whether the code was de-optimized before or not, and also the combination of the hotness and being actively in use. So there's a much smarter compilation queue, and it brings better results for the warm-up and for all the languages. This is one.
Yeah, because this is for us a focus area, since I think 2 releases now already that we are improving the warm-up situation for the Truffle-based languages, meaning for Python, Ruby, JavaScript. And it's still something we are constantly working on because it's probably the biggest issue left for something like Python on GraalVM to be viable in practice.
Right. And another important thing for the Truffle and is sort of related to the previous questions about JVM CI. So the new implementation and some API in the GraalVM 21.2 for the Truffle does require the new version of JVM CI. So specifically, if you are using the API for closing the context or interrupting the context, that requires an update to JVM CI. You can of course get the new JVM CI, and it will work without any problems in the GraalVM builds for all base JDK versions, right? On 8, on 11, on 16. But if you are using GraalVM languages with the different JDK, then you might want to make sure that the JVM CI changes have been implemented or not use this API, right? So as a workaround, you might not want to use this API or might not want to use the GraalVM compiler, which then, it will make everything slow. So in short, use GraalVM builds and be mindful of this kind of that version mismatch between the hotspot runtime and the JVM CI and the Graal compiler could create some issues for certain API if you're using them. Right.
Yeah. I mean, use the GraalVM builds, and if you're using the regular OpenJDK, then use the absolute latest versions of that OpenJDK.
Yes, I think the JVM CI is integrated in the early access for 17. I'm not sure exactly. I don't think it's in 16, but you have to check. The release notes has the exact versions of where it can be found. So if you are using that arrangement, then check those for sure.
Okay.
Right, and the last but not least part of the GraalVM project is the tooling section. And there are a number of improvements to VisualVM, right? And also we have the extensions for the VS Code IDE for your Java applications. And there are a bunch of those. And they're also one of the important ones, I think, or one of my favorite ones is that in this release, VisualVM gets the ability to respond to the commands from the other applications, right? So VisualVM has the API, and now the GraalVM extension in VS Code can also interact with VisualVM from your IDE. So if I go and install the GraalVM extension, so you just go to extensions and you search for GraalVM, there is now the pack. Wait, which one? Yes, I think it's called the GraalVM extension pack for Java. And you install those, and then you get this GraalVM icon here. You can manage your GraalVM installations for the release. And for example, you can also integrate with VisualVM. You can pick up the process. Let me pick the random one, a Gradle daemon. We've built native image.
Yes, that sounds interesting.
Gradle daemon, right? And I think it should. Where's my VisualVM? Let me close the VisualVM. Gradle daemon, run. I can run VisualVM and it should start. You don't see it, but it starts. See, now it started here with Gradle daemon. And you can monitor that normally. If you go to, for example, the sampler and you sample the CPU usage, and then it will show you the lines and the code, then you can go back. Wait a second, I will show you here. You can go back to the source, back into your Visual Studio Code IDE. So the integration is in both directions. You can also, just from the Visual Studio Code here, start, for example, the CPU sampler. So I will just include all classes and I will run that at a sampling rate of 100 milliseconds.
Right.
And then
cool.
While we're doing this, there is a question about the tooling. So Christoph is asking, are there any updates planned to the GraalVM dashboard? The current status is not useful for bigger projects. You want to take that?
There are, well, there are like improvements planned, but like when you say the current status is not useful for bigger projects, we are interested to hear your input from you, maybe via a GitHub issue, for example, or also just give us some more direct infos on what is the main things you would like to see to make it useful for you. I think, yeah, I mean, the dashboard has to a certain extent some scalability problems, maybe, that like if you have a very large app that it doesn't display accurately. But it's also a question of more like, you know, what feature do you want to have there? We certainly want to make the dashboard useful and extend it. We are also considering integrating it in one way or another into our GraalVM Visual Studio Code extensions. So you might not have to go to the website. So this is another update there. And yeah, in long term, it's certainly an area where we want to do more in terms of getting information from a native image build and displaying that nicely. Because we feel like that the static analysis during the image build has a very good view of your app. And we should be able to leverage that to give developers better insights into what is built into the image or what the application is about. But yeah, I mean, the answer is there are certainly updates planned. If you want to see specific improvements or a specific area where you think this would be the lowest hanging fruit that that the developers of this dashboard could work on, I'm happy to hear that. All right, and we hear now that GraalVM, the community edition build is online, so you don't have to do the dashboard, the dev build anymore.
Yeah, so it is there. The GraalVM Enterprise is supposed to be there as well, I think. So you can download both. It is based on contemporary JDKs. Here, one thing to note is that due to the complexity of the building on OpenJDK 8, that build is coming soon. If you're using Community Edition, the 11 builds are available currently for you, JDK 11 based builds.
Yeah, and in general, we are no longer recommending actually specifically for the Community Edition, we are no longer recommending Java 8. We will soon stop with Java 8 for the Community Edition because it is very difficult for us to build to have a sufficiently quality build of OpenJDK 8 to even build the GraalVM on top of it. So while we will continue to provide the 8 version for the Enterprise Edition that is based on the Oracle JDK 8, you can expect in one of the upcoming releases to that we no longer build the OpenJDK 8 version of GraalVM community. And in this release, it was very difficult for us to get the 8 build going. This is why we only have the 11 build here available at the moment for the Community Edition.
Excellent. Yeah, I think the GraalVM Enterprise builds are still waiting for some website to propagate the binary somewhere for the download, but they should be appearing there any moment. And we get the first happy user, Sane,
excellent, yes,
Sane in chat, saying that just the Quarkus demo application and building to native, and it seems 30% faster to produce the binary. Congratulations and thanks. Thank you, Sane. This is a very exciting result. 30% performance improvement for the build. I'll take that any day.
Excellent, cool. Thank you, Sana. That's awesome. Cool. Yes, we have another question here from Christoph. One more good measure. When would JDK 17 support be available? Could that be expected for 21.3? Would that be for 22.x at the earliest? So the current plan is to have it for 21.3 as far as I understand. So the current expectation is that we will have it available for 21.3. I think Java 17 is coming out. What's the release date on Java 17?
In September.
This is September. And then we will have okay, yeah, no, but yeah, we will have a release in October, so that should give us sufficient time. That should give us sufficient time to have a 21.3 that's based on Java 17, and to have that already in 21.3. Yes.
Yes. So one thing that you can do to kind of support us in that endeavor of having the builds on JDK 17 is to download, try, and evaluate, and give us all the feedback that you have about the builds for the Java 16 based GraalVM, because those builds are for the current latest Java, right? So and the incremental changes from 16 to 17 are smaller than the changes, for example, from 11 to 17, right? So test the available ones for 16. Give us feedback, tell us what doesn't work, tell us what works, give us some idea about whether the builds there are fast for you and expect to work the way you expect, right? If you build native images and so on, then that would be a sort of I think, the best proxy for out of the other versions how GraalVM on JDK 17 would kind of work.
Cool. Yeah, and yeah, so Sun says also the size of the binary was a little smaller by 2 megabytes, from 63 megabytes down to 61. That's awesome as well. And yeah, we are trying to optimize both metrics, meaning well, actually more than both. We are optimizing 4 metrics in the end on native image. One is the image size, one is the memory consumption, one is the startup, and one is the peak performance. And like most releases should see improvements in all these areas. Some a little bigger, maybe some a little smaller. If you find any regressions on these items between releases, let us know as a GitHub issue. And yeah, it's a priority for the native image team with these constant releases to every 3 months to get a little bit better and get a little bit more towards having here really an order of magnitude better execution for Java applications in the cloud.
And not just in the cloud, everywhere, right? Common applications.
Yes. In the public cloud, in your private cloud, and in embedded devices, of course. Yeah, we have this collaboration with the Microdoc team. So if you want to use GraalVM for embedded, we recommend you are looking at the Microdoc website. They are working heavily with GraalVM to bring GraalVM to even more devices and platforms. If you want it to run in some smaller device.
Right. I have just one more final thing that I wanted to cover today, and this is very close to my heart personally. Right. We have restructured the documentation for GraalVM, specifically the parts of the website that are on the graalvm.org, the reference manual, the examples, the configuration options, and all that. And all that information and that the sources for that, the website itself was open source already and was served by GitHub, but now the sources for that, the markdown files, are in the main repository oracle/graal. They sit there in the oracle/graal/docs folder, and you can contribute. So if you know some information about GraalVM, and if you feel that that information is not maybe adequately or in the best way kind of presented in the documentation, you can contribute that, right? You can change that. You can help make GraalVM the project you want it to be. And one of the examples of the PRs that was already contributed and landed and now is available as a part of the docs is how to use the JFR for the native image. And it was contributed, merged. So if you have a GitHub account, just go to the particular doc, click the edit button, implement the change, send us a PR, and we'll see how to implement that together. I know that there are certain questions where on the community Slack specifically where people ask about certain information, and I know that very often other members of the community get to respond and clarify before somebody from the team actually gets there. So yeah, I know that you know a lot about GraalVM, and now you can share that information and help us be a good open source project. So yeah, that's just
cool.
There are some instructions how to do that as well, but in a nutshell, that is just a GitHub pull request that you want to have. See, for example, this particular.
Cool, excellent. Cool, excellent. That's nice to have here the docs finally here in this structure to be easily contributable.
Yes. It is very cool because there are also examples. If you have particular integrations or particular configuration options that you want to highlight, the more power to you, the more power to the community. Right. This is everything that I wanted to kind of cover on this session. The binaries are there available. You can try at least the JDK 11 there is there, which is what most people are using, I think, currently.
Yes, and we actually recommend to at least use JDK 11 specifically if you want to work with native image. We recommend in any scenario not to use JDK 8 anymore at this point.
Very good. Right. We don't have any questions. So with that in mind, let's give it 20 more seconds.
Cool. Yeah, we already had a lot of great questions. Thanks everybody for joining us here and for making this a little bit interactive. This is what this should be about. We want the community to join us here on this unboxing stream. It shouldn't be just a monologue. It's great to see people engaging and giving live results and asking questions. So really awesome. Thanks for that. And yeah, thanks Oleg for all the demos. Everything worked. I don't know. How did you? I thought the demos would not work.
I thought something will I thought
was lucky.
one native
lucky.
image build will crush my machine here, but it was very fast, and probably because it's the new version that is faster and produces smaller binaries. Right. Anyway, we don't have any questions. If you have questions and we're not live anymore, please reach out to our community, reach out and ask questions on Twitter or on Slack or GitHub issues. Send us pull request, any feedback about the new builds, and use it. We'd be absolutely happy if you do that. Okay, Thomas is already frozen, so that is a certain sign that we should wind this up and see you next time. Thank you very much.